Very good afternoon to all of you. In previous lecture, we have seen the viscosity of the fluid, that uh, is nothing but is the resistance to the shear force. Okay, and we have seen the Newton's law of the viscosity, that is tau is directly proportional to the du by dy, and mu is nothing but your viscosity, or you can say that dynamic viscosity, coefficient of dynamic viscosity. And also, if we have seen the effect of temperature and rate of effect of temperature on the fluid, variation of viscosity to the temperature, and also we have seen the different viscosity of different liquids, kerosene, crude oil, benzene, etc. With respect to the temperature, this graph, and also in previous class you've seen the general law of viscosity for the non-Newtonian fluids, and then we have seen the kinematic viscosity nu, that is nothing but the ratio of dynamic viscosity to the rho, or that is nothing but mass density. The ratio of dynamic viscosity to the mass density is nothing but the kinematic viscosity. Okay, and it is measured in the stokes, and 1 meter square per second is equal to 10 to 4 centimeter square per second, that is 10 to 4 stokes. So 1 centimeter square per second is nothing but the stokes. Okay, so that is the measure of your kinetic viscosity. Now we will see today the compressibility. What is the compressibility? तो इससे पहले भी हम लोग ने डिस्कस किया कि लिक्विड को अगर हम कोई सिलेंडर में या कोई बर्तन में अगर हम रखते हैं तो वो बर्तन का शेप ले लेता है ना, लेकिन हम गैस अगर कन्फाइन करके नहीं रखे तो वो फैलते जाती है ना. इट इज द प्रॉपर्टी ऑफ द लिक्विड, and that is different between the liquid and gases. So all fluids may be compressed by the applicant of external force. So हम sorry. So by the application of force, we can compress the liquid. So we have seen in previous class that the properties of fluid, liquid or gases. So what is the effect of temperature? The effect of temperature on the liquid is that the viscosity is decreases. And what is the effect of pressure? That is nominal, very nominal. Similarly, on the gases also viscosity increases if we increase the temperature, because the internal molecular friction forces, that is increases if we heat the gases. Okay, so that is the effect of temperature on the viscosity of the liquid and the gases. Now today we will see the compressibility. Compressibility is that if you compress the fluid, so it will compress. It will compress by the application of external force. And when the external force is removed, the compressed volume of fluid expand to their original volume. हाँ, जिस तरह के हम लोग मैकेनिक ऑफ स्ट्रक्चर में या स्ट्रेंथ ऑफ मटेरियल में आपने पढ़ा होगा कि अगर कोई इलास्टिक मटेरियल है, हम उसको कंप्रेस करते हैं तो उसका शेप चेंज हो जाता है, लेकिन जब हम एक्सटर्नल फोर्स रिमूव करते हैं तो उसका शेप जो है इलास्टिक लिक्विड में है तो वो रिगेन अपने ओरिजिनल शेप में रिगेन हो जाता है ना. So that is we are saying that the elasticity. So when the external force is removed from the compressed volume of fluid, it may be liquid or gas, then it expands to their original volume, then it will come to its original volume. The fluid also possesses elastic characteristics. It means that okay, fluid also possesses the elastic characteristics like elastic solid. जैसे कि हम लोग ने एक elastic body का example देखा solid body का. So compressibility of fluid is quantitatively expressed as the inverse of bulk modulus of elasticity. So compressibility क्या है? It is the inverse of bulk modulus of elasticity, and bulk modulus of elasticity generally we denote by the letter K. Okay, elasticity K of the fluid, which explained below. So in analogy with solid, the bulk modulus is the modulus of elasticity for a fluid. It is the ratio of change in unit pressure to the corresponding volume of change per unit volume. So if you say that, so what is the bulk modulus? K is equal to, it is nothing but change in pressure to the change in volume. So here you can see that the K is nothing but stress upon strain. Yani stress, what is the stress? Change in pressure. Change in pressure is the stress. And this, our strain is nothing but change in volume to original volume. So generally we write that change in volume to original volume, that is dV upon dV upon V. So why? V is the original volume and dV is the change in volume. Why here negative sign? Negative sign is due to, because when we apply the pressure of the liquid or the gases, so generally the volume of the volume is decreasing. Volume is decreasing. That's why here the negative sign. Okay. So if you write down the bulk modulus of your elasticity of your fluid, so it is K times. If you will write like this, I will write the K is equal to what happens, Tp minus dV upon V. So if you write down, so what is the K modulus, bulk modulus? It is nothing but change in pressure. Dp is nothing but the change in pressure to the strain, and strain is nothing but that is change in volume to the original volume. That is nothing but our strain. Okay, so that's why change in pressure, if you say it is a stress, so K is the bulk modulus stress upon strain. That is nothing but K is equal to, this V will come up, so minus V into dP, V upon dV. In which the negative sign indicates that volume reduces as pressure increases. So in case of liquid, you can see that the volume of liquid, जब हम pressure apply करते हैं, तो volume of liquid क्या होता है? वो decrease होता है, कम होता है. Pressure हमारा जब बढ़ाएंगे, तो volume कम होगा. That's why this negative sign is there. The bulk modulus changes with the pressure and density of fluid. The bulk modulus किससे change होता है? It is with the pressure and density of fluid, but for liquid can be considered as constant for normal use. Therefore, the typical value of this bulk modulus is water is 2.05 Gn per cubic meter, that is giganewton per cubic meter, or oil is the 1.62 Gn per meter cube. The units are same as those of stress or pressure. Pressure generally we are using in megapascal, so it is a gigapascal. Okay, but it is not only the area. Here we are not only the area. Here we are considering as the volume. Here we are considering as a volume. That's why Gn per meter cube is there. Okay. So if you see the if this is the you can see that this box having the pressure from all the dimension. So three-dimensional box you can see. So here the pressure is applied from all the direction. The pressure is applied to all the direction. Therefore, the volume will change. The bulk modulus of this K is nothing but dP upon d, V upon V. Okay, so that is analogous to stress of strain. That is Young modulus of elasticity. So K is nothing but dP divided by dV upon V. So dP upon V is nothing but you can write down rho V is equal to mass, is equal to constant. So you know the density is equal to mass. Density is equal to mass upon mass upon volume. Okay. So rho V is equal to any density into the volume is nothing but the mass, and that is nothing but mass here is the box of the particle or the liquid is constant. Okay, so if you write that, so you can say that the dP upon rho is equal to minus dV upon V. So that is nothing but K is equal to 1 upon rho, d rho upon dP, and that is 1 upon rho, yani 1 upon bulk modulus is nothing but the compressibility. 1 upon bulk modulus is nothing but the compressibility. So here you can say that the compressibility is nothing but compressibility is nothing but it is the inverse of bulk modulus. It is the inverse of bulk modulus. Okay, that's why we have the bulk modulus, and then inverse of that bulk modulus is nothing but your you can say it is your compressibility. Now the another properties of your liquid is the cohesion, adhesion, and the surface tension. So generally the fluid particles, they attract each other, and that is called as the cohesion. So cohesion means that the intermolecular attraction between the molecules of the same liquid. Okay, that means it is the tendency of liquid to remain as one assemblage of the particle. So they are cohesion means they attract each other. They attract each other, and they will assemble as a one unit, an assemblage of the particle. So that is the cohesion between the molecules. So that is the intermolecular attraction between the molecules of the same liquid. It is called as cohesion. Intermolecular attraction, it is called as cohesion. But what is the adhesion? Attraction between the molecules of liquid and the molecules of solid body surface in contact with the liquid. है ना? तो यहाँ पर cohesion और adhesion, cohesion क्या है? It is the attraction between the molecular attraction between the molecules of the same liquid. और adhesion क्या है? It is the attraction between the molecules of liquid and molecules of solid bond, or in the molecules of solid bond. Okay, so the property of cohesion enables a liquid resist tensile stresses. The property of cohesion enables a liquid resist tensile stresses, while adhesion enables it to stick to another body. Another body, and a liquid is stick with the another body. है ना? वाटर हम देखें कि ड्रॉपलेट आपका छत से जो टपकता है वो बहुत देर यानी इट विल बी विद द सॉलिड, आपका स्लैब है या आपका छज्जा है या आपका वुडन कोई भी हो, तो वो गिरने से पहले बहुत इट विल बी एडिशन टू द डेट सरफेस. तो सॉलिड सरफेस और लिक्विड सरफेस के बीच में जो अगर आप बोलेंगे अट्रैक्शन है तो उसको हम क्या बोलते हैं? एडिशन बोलते हैं. लेकिन अगर इंटरमोलिकुलर अट्रैक्शन लें बिटवीन द लिक्विड, तो द सेम बिटवीन द पार्टिकल्स ऑफ सेम लिक्विड, इट इज कॉल्ड एज कोहेशन. तो ये डिफरेंस है. कोहेशन सेम लिक्विड के बीच में होगा, इट इज इंटरमोलिकुलर अट्रैक्शन, है ना. एडिशन क्या रहेगा? लिक्विड और सॉलिड के बीच में रहेगा, है ना. So that is the difference between cohesion and adhesion. And the property of cohesion enables liquid resist tensile stress. Cohesion of property is that the liquid resists the tensile stress, while adhesion enables it to stick to another body, यानी सॉलिड सरफेस से, किसी भी बॉडी से आपका लिक्विड एडिशन है या अट्रैक्ट है, तो दैट इज कॉल्ड एज addition. Now surface tension is due to cohesion between liquid particle at the surface. What is the surface tension? Surface tension is due to cohesion between liquid particle at the surface. Cohesion between liquid particles at the surface means दो सरफेस, लिक्विड पार्टिकल और गैसेस, है ना, जैसे कि पानी है और हवा, है ना, तो ये दोनों क्या है आपका, दैट इज नथिंग बट योर लिक्विड एंड गैस, है ना। तो सरफेस टेंशन इज ड्यू टू द कोहेशन बिटवीन द लिक्विड पार्टिकल्स एट द सरफेस, यानी जो लिक्विड पार्टिकल्स आपके हैं यहाँ पर अगर आप देखेंगे कि तो फ्री सरफेस ऑफ वाटर, है ना, या एनी लिक्विड, है ना, तो देयर आर 1 2 3 टाइप्स ऑफ मॉलिक्यूल्स आर shown. 3 types of molecules are shown, A, B and C. A, B and C. So surface tension is due to cohesion between the liquid particle at the surface, whereas capillary is due to both cohesion and adhesion. तो यहाँ पर हम लोग surface tension पहले देख रहे हैं। तो आप देखेंगे कि you will see this figure, आप ये figure देख रहे हैं मेरे ख्याल से। तो यहाँ पर आप देखिए A, this one is the A, this particle is the B, and this particle is the C. ओके, तो आप यहाँ पर देखिए कि अगर हम उसको एयर पकड़े, दिस इज योर वाटर, तो यहाँ पर आप देखिए कि ये जो पार्टिकल ए है या मॉलिक्यूल ए है ना, इसके सराउंडिंग पूरा लिक्विड है, तो इट इज ये लिक्विड क्या है, इसके ऊपर कोई चेंजेस होगा क्या, नहीं होगा। ओके, लेकिन अगर हम यही सरफेस पर आए, तो यानी ये जो पार्टिकल अगर हम ये मॉलिक्यूल हम देखते हैं तो सी, ओके, तो हियर द मीडियम इज हियर एंड हियर द मॉलिक्यूल इज, आई एम शोइंग हाउ इट इज attracted by the same liquid, so here it will be the cohesion force, and here if you see it is nothing but the adhesion force, due to this adhesion and cohesion the surface tension will create at the surface of the surface of the liquid. यहाँ पर surface tension रहेगा क्या, नहीं, ये पूरा चारों तरफ से लिक्विड से घिरा हुआ, तो यहाँ पर नहीं रहेगा, लेकिन यहाँ पर जो अबव पोर्शन है उस पर रहेगा। तो व्हाट इज सरफेस टेंशन? सरफेस टेंशन is defined as tensile force acting on a surface of liquid in contact with gas or on the surface between two immiscible liquids, such as contact surface behaves like a membrane under tension. So this contact surface, it behaves like a membrane under tension. The magnitude of this force per unit length of free surface will have same value as surface energy per unit area. It is denoted by Greek letter. The surface tension is denoted by the Greek letter, that is sigma. In case unit, it is expressed in kgf per meter, while in SI unit, the surface tension, it is Newton per meter. Okay, so once again I will read that so that you can understand. The phenomenon of surface tension is explained by this figure 1.10. Consider 3 molecules A, B, C of liquid, A, B, C of liquid in a mass of liquid mass में the molecule A is attracted in all direction equally. तो हमने अभी पढ़ा कि कोहेशन क्या है, इंटरमॉलिक्यूलर अट्रैक्शन, तो A के चारों तरफ क्या है, सेम टाइप का लिक्विड है, तो यहाँ पर क्या बोल रहा है, मॉलिक्यूल A is attracted in all direction equally by surrounding molecules of liquid. Thus, the resultant force acting on the molecule A is, the resultant force on A is 0, है ना? But if you see the molecule B or C, but the molecule B, which is situated near the free surface, is acted upon upward and downward force, which are unbalanced force. So here unbalanced force here. Here the cohesive forces are there. The molecules of the intermolecular attraction is there between the liquid and this molecule, and there is air, so there is adhesion also. So there is unbalanced force because the downward force, they will attract, the intermolecular attraction will adhere to the molecule B, whereas the adhesion due to the another surface, another free surface, or air you can say. So that's why there is imbalance force. There is imbalance force between the free particles. So which is situated near the free surface is acting upon upward and downward forces. And both forces are there. You can say the downward forces is the intermolecular cohesion, and upward forces due to the different material, different medium adhesion. Okay, and the molecule C situated in the downward direction. The molecule C situated on the free surface liquid does experience a resultant downward force. All molecules on the free surface experience a downward force. Thus, the free surface of liquid acts like a very thin film. Thus, the free surface of liquid a very thin film under tension of the surface liquid act as though it is an elastic membrane under the tension. तो यहाँ पर क्या होगा कि आप देखेंगे कि this is if you say it is the gas molecules, is dark colors. Okay, you have the gas molecules, and the blue colors is your liquid molecules, the liquid molecules. Okay, and this is our free surface. This is our free surface. Okay, free surface is there. So what happened? There is at this P, the liquid, there is intermolecular attraction between the liquid, but here the adhesion due to the gas and the free surface. So what happened? There is the film, is small film produced, and this is called as the surface tension. That is called as surface tension. So around the surface there is tension on the surface due to these two unbalanced forces. So that is called as surface tension. Okay, so this is due to the property of adhesion and the property of adhesion and the cohesion between the intermolecular attraction. Okay, in the liquid. The same thing is here at the interface of liquid and gas. Net force due to imbalance of cohesive like molecules and adhesive forces, unlike molecules, any gas or liquid, as seen in this figure. Okay, the interface surface, the interface surface of the liquid acts like a stress elastic membrane. So interface surface at the liquid, this surface, it will act like a stretch. It will act like a stretch membrane. Membrane. Okay. So or stretch elastic membrane under tension. Then the pulling force that causes this tension acts parallel to the surface and is due to the attractive force between the molecules of it. The pulling force due to the tension acts parallel to the surface, and parallel to surface means if you see this droplet of water, you can see this at the surface. This I will change the color. So you can see here. I will draw. So this is your half part of the drawing of the molecules or droplet of water. Okay, so if d is the diameter or r is the radius. Okay, so this is outside is the gas, external if you write the gas, and inside this is the liquid. There is a cohesive force between the particle of liquid, and around the surface it is nothing but the, you can say, the surface tension or that force that due to this the tension is there. So that you can say what is here? The pulling force that causes this tension acts parallel to the surface and is due to the attractive force between the molecules of the liquid. Due to the attractive force between the liquid. The magnitude of this force per unit length, the magnitude of this force per unit length is called as surface tension. So magnitude of that force per unit length is called as surface tension. And that's why the unit of the surface tension is nothing but the Newton per meter, and dimension Newton is nothing but you know that if you convert Newton is the kg into meter per second square, okay, into per meter, okay, kg meter per second square divided by meter. So it is mass into meter per second square per meter, mass into this meter we will get cancel, and then only time is there showing out of time. So that's why the dimension of this surface tension is mass into inverse of or divided by, so it is nothing but Newton per meter. Okay, typical value of water, the surface tension of water is 0.074 Newton per meter at 20 degrees Celsius with air. So if water and air are there, two mediums are there, if you consider, then the typical value of the surface tension of water as 20 degrees Celsius, it is 0.074 Newton per meter square. Okay, so surface tension decreases with the liquid temperature. Surface tension decreases with the, why the surface tension decreases with the liquid temperature? When we heat, when the temperature increases, what happens? The cohesive intermolecular cohesive forces are decreasing. Intermolecular cohesive forces are decreasing. That's why the surface tension surface tension decreases with the liquid temperature, because intermolecular cohesive forces are decreasing. तो यहाँ पर हम लोग देख रहे थे कि the pressure inside, so it is nothing but it is dependent in liquid due to the cohesion forces. It is depend on the free liquid. Okay, so it is nothing but if you, between the pressure difference between the, we write to delta P, that is the difference, and this is the area. Area is nothing but pi r square, area of the circle. So area of the this surface is pi r square. So delta P into pi r square. So it is equal to the surface tension, that is sigma. Sigma कहाँ पर act हो रहा है? At the periphery, at the boundary, it is a boundary of droplet it is acting. Okay, so you know that the periphery or perimeter of the circle is 2 pi r. So it will be right. So difference in pressure delta P. So any pressure in liquid and pressure in gas, that is nothing but delta P. If you combine it, it will be called as delta P. So delta P into, it is on the area that is pi r square, it is equal to the pressure difference at the interface is delta P pi r square. It is nothing but surface tension, that is sigma, into where it is acting sigma, it is around the periphery of the particle or droplet of water, so that is sigma into 2 pi. So this is the pressure difference at the interface. You can understand. Okay, so this is nothing but the sigma is nothing but your surface tension. The sigma is nothing but your surface tension. Okay, so P delta P pi r square is equal to sigma 2 pi r. Sigma 2 pi r. So if I will write down pi, if I will write down P is equal to, if I write down delta P is equal to sigma 2 pi r upon pi r square. So this r will be cancelled, this pi will cancel, so it will be 2 sigma, 2 sigma upon 2 sigma. So change in pressure, it is nothing but 2 sigma upon r. Okay, so that is if the droplet of water if you consider, so that pressure difference, there is delta P, delta P, delta P is nothing but, delta P is nothing but 2 sigma upon 2 sigma. Okay, so that is nothing but the surface tension. Or we can write down in terms of sigma, it may be delta P to R on 2, delta P to R 2. Okay, now the angle of contact between the solid surface and the tangent to the surface of the liquid at the contact point. So here there is two condition कि आपका जो surface है वो wet होगा या नहीं wet होगा. So if the context, if the angle between the solid surface and tangent to the surface of liquid, so if this is the droplet and this droplet making a tangent that to the surface, and the angle between the two surface is greater than theta is greater than 90 degree, is greater than 90 degree, then it is said to be non-wetting current, non-wetting condition. So that your solid surface will not be wetted. But if the angle of this tangent to the liquid surface is gas, one medium, liquid, another medium, solid, another medium, okay, another surfaces are there. So if this surface tension, it is making the angle less than 90 degree, less than 90 degree, it means that it will wet the surface. Will the surface. So that is nothing but it is called as an angle of contact. Nothing but called as angle of contact. So in this properties of fluid, the part 1 of your unit 1, you have studied many things, many properties of the liquid. From the start, you can see that is the we are sorry is dimension of the lower. So what we have seen the physical properties of the, we have seen the density, the mass upon the volume. We have seen the specific volume. It is nothing but specific volume defines volume per unit mass. It is nothing but 1 upon rho, 1 upon density. And specific gravity is nothing but the specific gravity, that is the density of any substance to the density of water, or you can say the weight of any substance into the water. It is nothing but specific gravity, specific weight of unit volume of substance. It is generally denoted by the gamma, and gamma is equal to rho into g. Rho is the density, and g is the gravitational acceleration. Gravitational acceleration generally we are taking as 9.81 kilonewton per sorry 9.81, okay, and meter per second square, and if Newton, it is 9810 Newton per meter centimeter per second square. And here you can see that the specific weight of water is nothing but is 9810 Newton per cubic meter of specific weight of, if you mercury, it is 13.6 times the specific weight of your water. So here the density of water is 100 kg per cubic meter, density of mercury is 13,546 kg per cubic meter. Density of air is 1.23 kg per cubic meter, and paraffin is 800 kg per meter. Then you have seen the relative density, that is specific gravity, and viscosity. We just previous lecture we have covered, and that is mu. Mu is nothing but the coefficient of viscosity, dynamic viscosity, and that is nothing but the ratio of shear stress to the rate of shear strain. Here, why the rate of shear strain? Because in liquid, the continuous change of shear strain will take place. Uh, and then you have seen the Newtonian fluid, that is dilatant and pseudoplastic, and we are also seeing the shear thickening and shear thinning. Shear thinning. What is the shear thickening and shear thinning? What is the shear thickening? It means that as we go, as the deformation goes increasing, we require more force to maintain that deformation. But in shear thinning, as we go, as the rate of deformation changes, we need less force for the shear deformation, and that's why it is called as shear thickening. When we need more force for the shear deformation afterward, and that is the solution with the suspended starch or sand. And in case of shear thinning, we the decrease of mu, that is dynamic viscosity, decreasing at the later stage, and that is with increase of deformation rate. That is the shear thinning fluid. And we need less force for the same rate of deformation. And it is nothing but, the example is paint and polymer, we have already seen. And then the Bingham plastic. Bingham plastic किसको बोलेंगे कि हम अगर फॉर एग्जांपल यहाँ पर एग्जांपल दिया टूथपेस्ट का, तो आप देखिए कि टूथपेस्ट हम जब प्रेशर अप्लाई करते हैं टूथपेस्ट पे, तो फौरन पेस्ट हमारा बाहर निकलना शुरू होता है क्या? नहीं निकलना शुरू होता है। तो वो इनिशियल कुछ फोर्स लगता है, तो इसलिए आप यहाँ पर ग्राफ में भी देखेंगे, तो बिंगम प्लास्टिक के लिए यहाँ पर देखिए इनिशियल कुछ स्ट्रेस लगेगा, कुछ फोर्स लगेगा। देन उसके बाद क्या होगा कि वो कंटिन्यूअस आपका टूथपेस्ट बाहर आना शुरू हो जाता है। तो दैट टाइप ऑफ फ्लूइड is called as Bingham plastic. So it resists the financial stress and then deform continuously. पहले तो कुछ रेजिस्ट फेस करेगा, इसलिए हमको थोड़ा सा फोर्स लगता है इनिशियल टाइम में, उसके बाद कंटिन्यूअस डिफॉर्मेशन, कंटिन्यूअस पेस्ट आपका बाहर आना शुरू हो जाता है। दैट इज द एग्जांपल ऑफ योर Bingham plastic. So ये already we have seen, and then we have calculated the unit of viscosity. How to calculate? I have shown this here. How to calculate the unit of viscosity? This tau upon du upon the shear stress is nothing but change of velocity to the change of distance. Yani it is also called as velocity gradient. It is also called as velocity gradient. And shear stress tau is nothing but it is force upon area. From that you have find out the unit of viscosity. Okay. Then variation is the temperature for liquid. When you increase the temperature, so your viscosity decreasing. That's why here you can see the inverse. It is given. And for gases, if you increase the temperature, the viscosity increases. That's why it is proportional to the viscosity. Okay. Then viscosity of some of the liquid, that is with respect to the temperature. Okay. So in air you can see, in the gases it is increasing, but in the liquid, as the temperature increasing, the viscosity decreasing. Okay. That graph you have seen. And then we generalize law of the non-Newtonian fluid. Okay. That is A plus B to the power of n. That is the rate of du by dy is nothing but velocity gradient to the power of n. Okay. Also we have seen the dynamic viscosity. It is nothing but mu upon rho. Rho is the density and mu is the dynamic viscosity. And it is measured in the stroke. So 1 meter square per second is nothing but 10 raised to 4 centimeters square per second. That is 10 raised to 4 is. Okay. Then compressibility we have seen today, that is nothing but K is equal to change in pressure to the strain. And strain is nothing but changing volume to the original volume. And today we have seen again the surface tension, surface tension. Okay, and surface tension we have seen. What is the cohesion? Cohesion is between is nothing but intermolecular attraction between the polymer and adhesion is the attraction between the at the boundaries, the molecules of liquid and the molecules of solid or molecule of air, you can say. So also we have seen the how explanation of the surface tension. It is due to the imbalance force between the cohesion and the adhesion is nothing but the surface tension. And then what is the surface tension? The unit of surface tension. And the surface tension for water at 20 degrees Celsius with the air is 0.074 Newton per meter. Okay, and then how we can calculate the pressure difference if you know the surface tension, or how to calculate the surface tension if you know the pressure difference. This formula you can use for that. Then also we have seen today the angle of contact. So the surface will wet or surface will not wet. It depends on the angle of contact. If the angle of contact is more than 90 degrees, the surface will not wet. And for angle of contact, your surface tension is less than 90 degrees, then surface will wet. Okay, so this is all about your unit number 1, part A, about the properties of fluid. And part B of your unit is nothing but the fluid statics, and it is start inshallah from tomorrow. So tomorrow we will solve first one or two example on the this properties of fluid, and then we will go for the our for next class we will go for the fluid statics. Okay, so this small definition: density is the mass per unit volume. Specific volume is the volume per unit mass. Specific gravity is the ratio of density of substance to the density of water. Specific weight is the weight of unit volume of substance. And surface tension is nothing but force acting per unit length at the interface. As you have seen in the plate. Okay, so this is for the today, and tomorrow inshallah we will solve some example which will ask previously. Uh, okay, so asked previously also some of the from the textbooks. So textbook you can follow. It may be the hydraulics and fluid mechanics by the P.N. Modi and Dr. H.M. Seth, and also Dr. R.K. Bansal, and also some books available in library by the Dr. Suresh Grande, etc. You can go through that and make your notes. I'm also sharing my notes on the Google Classroom, so you can also take from there. If you have any question, you can ask with me, or otherwise we will stop here. I request all the students that they will join the lecture on time, so that there should not be a disturbance. And your attendance is recording and joining. Recording all the details, your details will come. I request all the students they will join lecture on time. Okay, I am already starting the lecture on time. So if you have any question and that period when you are joining, so before the start of lecture you can ask, and after the end of the lecture you can ask me if you have any doubt. So we will stop today here and continue tomorrow with the example.